So here we go. So when the boy is given a little nudge, what happens is we could assume that he starts with the initial velocity is so negligible that it could be considered as zero. That means the kinetic energy at that initial condition at A, right? At A, I'm going to say A here, is equal to zero, okay? Because it doesn't have anything. Now, and it slides down ice, show that he leaves ice at point whose height is this much. When he reaches this height, his butt's going to be not contacting the ice anymore. And it is frictionless ice, therefore work done by non-conservative force is equal to zero. Therefore, we can use the total energy initial is equal to total energy final. Okay? So those are given to us. And here is our position A, here's our position B, right? Position B is right here. And then at position B, we have FG going straight down like this. And this FG can be broken up into its FGY, which is actually FG radial, because it's along the radial direction. And this is your FGX, right? This is just like inclined plane, right? And this is the right angle. And this angle here is theta, just like this angle theta right here, okay? Because, you know, transversal cutting through two parallel lines, ultimate interior angles are congruent. All right, so once we know that, when this happens right at this location, your normal force here, which should be in this direction, your F normal goes to zero. It vanishes. That's when the butt is not in contact with the ice. Okay. So if we were to take a look at sum of all forces along the radial direction at point B, it is equal to MAC. Okay. And at radial direction at point B, there should be two forces going on, right? There should be F normal, right? There should be F normal, and there should also be FGY, okay? Now, since A sub C is going in this direction, that direction will be positive. Therefore, FGY will be positive, okay? So MAC is equal to, now F normal goes to zero because it vanishes. Therefore, only thing we have is FGY. Now, FGY is, we know FGY is equal to mg cosine theta because that is the adjacent, right? So mv squared over r is equal to mg cosine theta. Well, it would be really nice to know, well, masses cancel out, what the cosine of theta is. But we don't. We don't know what the theta is, so we can find out what cosine of theta is. However, we do know that this right here, right, is the height. This is the height. And this hypotenuse right here is the radius r. So we can actually represent this cosine theta as cosine theta is actually, right, adjacent over hypotenuse. So we can substitute this into my cosine theta. So here we could say v squared over r is equal to g times, right, h over r. Well, look at this. R's can cancel out nicely. giving me that V squared is now equal to GH. So this is good to know. We're going to use this later at this point, right? This V is at point B. Now, if we were to take energy consideration on this, okay, we know that total energy at point A is equal to total energy at point B. That means here, what are the possibilities? Well, I could have kinetic energy at A plus the potential energy, gravitation at A. There's no spring involved, so I'm not going to have to worry about the spring potential energy, right? That has to equal to kinetic energy at B plus the potential energy gravitation at B. Well, we already mentioned that kinetic energy at point A was zero because the slight nudge was negligible velocity, so we could say that's zero. Okay. So what is the potential energy at point A? Well, that is mg. Height happens to be the radius of r. Here, the kinetic energy is 1/2 mv at B squared. And that's this V right here, plus mgh. So if we substitute this V squared into here, what we get is mgr is equal to 1/2 times m times gh plus mgh. So notice what happens to my m gets canceled, g gets canceled. So what do I have? I have r is equal to 1/2 h plus h. That is 1.5 h. So if I solve for h, it becomes 2/3 r. All right. Well, if you want to figure out what is this angle, right? You could figure that out. So cosine of theta is equal to h over r. We can substitute the h now with 2/3 r, right, over r. So theta is equal to cosine inverse of, well, r over r can cancel out, giving me just 2/3 here. So theta comes out to 48.2 degrees. That's just little, you know, going a little further